Hello everyone, my name is Yuriy Zaychik. I am Java developer at Luxoft, and today I want to talk with you about foreign function and memory API in Java. So at first let's have a look at our agenda. We will start with a little introduction about the reasons why we have such API and what are the use cases for it. Then we will talk in details about the project Panama. After that, we will discuss the advantages of the project Panama over the current Java native interface API. And finally, we will have a look at some code examples. So let's start. We all know that for years we have such a slogan in Java like write once, run everywhere. And by now there are hundreds of different libraries and projects which are written in pure Java, and you can easily add them to your project using various build systems like Maven, Gradle, and so on. And if you want some interaction between different software units, you can use network sockets, shared input-output resources like files, databases, and so on. But still, sometimes we need to use some foreign binary code which is not controlled by JVM, or some memory which is also located outside the JVM. So what could be the cases for this? For example, today the popular topics are machine learning and data science, and if you want to use some powerful data science libraries like TensorFlow, for example, you will need some way to bind this binary code to your application. Or, for example, you can imagine a system where we have different services, and each service is written in different language. So we can have Java service, Python service, and JavaScript service, and so on. But we need to share some common algorithms, for example, for security or some cryptographic algorithms. And each service performs some operations using these algorithms. And it would be a bad idea to implement those algorithms for each language that you have. And it would be a hell to support all of this. So the real case would be if you have some binary library with those algorithms, and it can be shared between all of the services. And for this case, you will also need to somehow bind this code to your application. And currently, such approach in Java is called Java native interface, but Java architects wanted to create the new approach, and they started Project Panama, which is held under Java Enhancement Proposal Program, which is a part of open JDK community processes. And in this GEP, Java architects and community members propose some new Java language features or JVM features. And while those features are in development stage, you can still use them even in some JDK releases, but they are marked as preview features, and to use them, you will need to explicitly enable those features. And also, you shall not rely on the experimental features. Don't use them in your production code, but this is good case to do some R&D in your project, and also to help develop the Java language and to help the community. So what are the objectives of the project Panama? So the first one is to call native functions from Java and to substitute JNI in this. Then provide convenient access to foreign memory, and which is not controlled by the JVM. Also create some kind of automatic parsing of header files of binary libraries, native library management, native GIT compiler optimizations, and much more. And why this project received such name, Panama? This analogy was proposed by one of the virtual machine architects, John Rose. So we know that the Panama Canal joins together Pacific and Atlantic oceans. So vessels don't need to make huge detours over the North or South America continents. They can easily pass through the canal. And so for this project is also meant to make some convenient approach to create a bridge between the JVM and the foreign binary code and foreign memory. So what is this foreign function and memory API main objectives and what classes we have there? So the first one is to allocate foreign memory, and for this we use memory segment and segment allocator classes. Then we need to easily manipulate and access structured foreign memory. So for this we use memory layout and war handle classes. And also we need to control the allocation and deallocation of the foreign memory. And for these purposes, the segment scope and arena classes are used. And finally, we need to call foreign functions and manage native code libraries. And for these purposes, we use linker, function descriptor, and symbol lookup classes. So now let's have a closer look at some of these classes. Let me switch to the next slide. So the first class is called memory segment, and this class provides access to a contiguous region of memory. And there are two kinds of memory segments. A heap segment, which is backed by and provides access to a region of memory inside the Java heap. And the second kind is a native segment, which is backed by and provides access to memory outside the Java heap. Native segments can be obtained by calling one of the allocate native factory methods from this interface, and alternatively, native segments can be obtained by mapping file into a new off-heap region of memory, and such memory segments are called map segments. And every memory segment has an address expressed by a long value, and the nature of this address depends on the kind of the memory segment. So for the heap segments, this address is not a physical address, rather some offset within the memory region which backs this segment. And for native segments, this address denotes the physical address, and the same for the mapped segments. The physical address of the region of memory which backs this segment. So the next important interface is called Arena. And this interface controls the life cycle of memory segments, providing flexible allocation and timely deallocation. Arena has a scope called Arena scope, and when the arena is closed, the arena scope is no longer alive, and all memory segments associated with the scope are invalidated, and their backing memory regions are safely and atomically deallocated where it's applicable, and can no longer be accessed after the arena is closed. But if you want to use this arena class in some multi-threaded application, you need to be very careful, because to ensure the correctness of this valid closing and invalidating memory segments in this case is much more complex. So let's go further. So the next important interface is called linker, and this interface provides access to foreign functions from the Java code, and vice versa. It provides access to Java code from foreign functions. These foreign functions are typically located in the libraries, which can be loaded on demand, and each library conforms to a specific application binary interface, which is a set of calling conventions and data types associated with the compiler, operating system, and the CPU where this library was built. Linker has a detailed knowledge of the calling conventions and data types used for specific ABI. And for any library which conforms to that ABI, the linker can be some kind of a mediator between the Java code and the foreign binary code. So in particular, linker allows Java code to link against foreign functions using so-called downcall method handles. And it also allows foreign functions to call Java method handles using upcall stubs. Okay, so let's go further, and the next class is called, the next interface is called symbol lookup. The objects that implement this symbol lookup interface are used to retrieve the address of a symbol in one or more libraries. By symbol, we mean a named entity, which can be a name of some function or a global variable in some library or a set of libraries. Symbol lookup is created with respect to a particular library or set of libraries, and the method find, which takes the name of a symbol, is used, and it returns the address of the symbol in the library. And this address is modeled by a memory segment, which we can use in different ways. So it can be passed to a linker to create the downcall method handle. It can be passed to an existing downcall method handle as an argument. It can be stored inside another memory segment. Or it can be used to access the foreign memory backing some global variable, and so on. Now let's also have a quick overview of the history of development. This function, foreign functions and memory API during the releases of the JDK. Okay. So the first iteration, or in terms of JEP, the first incubator of this project appeared in Java 14. And the goals for that time were generality, safety, and determinism. By generality, we mean that we need to operate with different kinds of foreign memory, like native memory, persistent memory, managed heap memory, and so on. We need to accommodate different platforms and foreign functions written in languages other than C. By safety, it was meant that this API shall allow programs to perform unsafe operations, but it shall warn users about the possible risks of such operations. And by determinism, it was meant that the API should be developer friendly and use clear and convenient ways to reach these goals. In Java 15, the customizable memory handles appeared, also the support of mapped memory segments, the thread safe API points, dereferencing of addresses from native calls. Then in Java 16, foreign linker API appeared and support for the shared memory segments. Then in Java 17, the focus was switched to ease of use and to the multi-platform support. Then in Java 18, more carriers as var handles appeared. The simpler API for down call method handles and also the management of temporal dependencies was also simplified. Also, the new API to copy Java arrays to and from memory segments was introduced. In Java 19, there were no new features, only some performance optimizations and improvements of the already defined features and goals. And finally, in the latest release in Java 20, the memory segment and memory address abstractions were unified. Sealed memory layout hierarchy was introduced and enhanced for the new pattern matching language feature. And memory session has been split into arena and segment scope. And now let's talk about the problems with the Java native interface. So why the architects wanted to create the substitution for this approach, why they consider it brittle and inconvenient. So the first thing is that developers need to deal with a bunch of tedious artifacts. So you need to create a Java class that reflects native methods. You need to create a header file derived from this class. Also, you need to create the implementation file, which in its turn will call native library methods. And if the native library that you want to bind to a project is rather big and it evolves rapidly, then you will have hell supporting all these artifacts from version to version. The second thing is that JNI can only be used with C, C++, or assembly native code since it uses the calling convention between operating system CPU for which the JVM was built. And finally, JNI doesn't provide some convenient mapping between Java type system and C type system. So to interchange your data between the JVM and the native code, developers either used the direct byte buffers. So in this case, you deal with some you don't longer deal with some structured data. You deal with some faceless bytes, or they can use the unsafe API to allocate off-heap memory and pass the address to this memory to a native method. But this approach is rather vulnerable. Now let's have a look at some code examples for this project Panama. So at first, to use it, we will need the latest JDK for Java 20. So I've already installed it. Let's check. So as you can see, I have Java 20 installed on my machine. So, and now let's use IntelliJ to create the new project. So let's create a new folder, called it Panama, and let's call the project Panama as well. So the new project is created, and now let's try to use some code from the standard C library. Okay, so we have our main method, and to add the code from the native library, we will need to use a linker. So let's define it. Let's call the variable native linker, and we will use linker interface factory method native linker. And also let's create a library lookup. Let's call it standard lib lookup, and we will use a native linker to use the default lookup. And also let's create the lookup using symbol lookup interface. So we'll call the variable loader lookup and use symbol lookup interface and loader lookup factory method for this. And we declared all these variables to create the downcall method handle for some function of our standard library. So we created all these variables obtaining the downcall method handle. So now let's declare this method. So first we will try to use the loader lookup. We'll use method find, and also let's define what function from standard lib we will use. So let's try to call the printf function. So let's define its name. So let's pass it as an argument. And if this loader lookup fail, then we'll try to use standard lib lookup and also use method find for the same symbol. Then we will map this to a memory segment and let's use the native linker for this. We will call the method downCall handle, which receives the memory segment. So like both find method of the lookups, they return the optional of the memory segment. And we will map this memory segment to a downCall method handle. And also for creating it, we will need to provide the function descriptor. And in this descriptor, we shall pass the value layout parameters, which will denote the return type and the input of the native function. So this we have value layout interface, which models basic data types like integral types, int, long, and so on, floating point types, and address types. And it has convenient constants for data type. So as a return type, we use integer, and as an input parameter, we will use the address constant. Since we are dealing with optional, we need to provide something in case they both lookups fail, but we are doing this in the sake of simplicity, and in real cases, you know that returning null is a bad practice. So let's format this code a little. And now we will need to create the arena where we will define the foreign memory variable and use this downCall method handle. We will pass this foreign memory unit to it and then see what happens. So the arena also extends auto-closable interface, so we can use the try with resources construction here. So let's call it of heap and to use arena factory method open confined, so it will returned a new confined arena for this particular thread. And now let's define a memory segment for some data that we will pass to the printf function. So let's call it, for example, hello segment. We will use off heap. We will allocate the UTF string, and let's type here something like hello from Java 20. Okay, and then we use this downcall method handle, call the method invoke, and pass this reference to a memory segment. And have a possible exception here. So let's catch it, and let's compile this and see what happens. You can see the compilation failed, and as I said, since this is a preview feature, we need to provide enable preview option for the compiler. In the IntelliJ, you can resolve this by going to the project structure, and here in the language level, you can use the option preview. So then this code now could be compiled properly. So yes, the code compiled, and now let's try to run it and see if it works. So again, since we use the preview features, we need to explicitly add JVM option like enable native access and also you may pass it here as virtual machine options. Then you will want to receive these warnings. But as you can see, our code worked, and the printf function could output the value that we provided from the JVM. Panama also has a useful tool which is developed also in the scope of this project, but it is delivered separately from the JVM modules, and this tool is called jextract, and it is used to conveniently find some native library to your Java project. So you just need to provide the .h file from some C or C++ library, And this tool will generate Java classes, and then you just need to include these Java classes to your project and easily use the foreign functions from this library. So now let's have a look at an example of how to use this jextract tool. So I have already downloaded the binaries for this tool, and let's try to find our standard input-output library to Java. And also for these purposes, I've installed min.jw. And like we use the following options. We need to generate source code. We need to provide the location for output and the name of the packages for the Java code. So let's start it. You can see that we have src directory. And here we have our Java code for stdio library. So now you can easily copy this code to your application. So IntelliJ needs some time to refresh its indexes. So you can now see that we have all these classes here. You can now see that if we use import foreign code, for example, let's use import static for some particular function. And also let's call our standard library package, and for example let's use one of the printf function implementations. Okay, so now let's consider this approach. So let's remove this method handle. Let's provide our reference of the off-heap memory to this static function. Now let's see if it works. So you can see that it also works successfully. So thank you very much for participating in this event. I hope that this session was interesting for you, and if you have any questions, you're welcome to our Slack chat. So thank you very much, and goodbye.